All right, so let's talk a little while about the integumentary system. When you think about the integumentary system, you basically can just think about the skin and its associated structures. Hang on. Totally non-COVID related sneeze. The skin accounts for 10 to 15% of total body weight, making it the largest organ in the body. Again, that's one of those trivia questions that comes up every once in a while. I saw it on Jeopardy one time a few years ago. It's more than just the outer covering. It is a complex organ with many functions important to homeostasis. And remember, homeostasis is that idea of keeping a relatively constant internal environment. The cutaneous membrane is the skin. It has two major components. The epidermis, which is the superficial layer. That's the keratinized, stratified squamous epithelium resting on a basement membrane. It's the epidermal cells that when you're on the CSI shows and you see them talking about, oh, hang on, I moved my camera a little bit. Sorry about that. But when the CSI shows, when they're talking about they found epithelial tissues or epithelial cells on the rope that had the crime victim tied up. Apologize, forgot to silence the phone. Okay, that's two. But it's those epidermal cells that you're leaving behind when you tie up a rope or when you take off a glove and they find the cells inside the glove. Those are epithelial cells or epidermal cells. The dermis is deep to the epidermis, and if you'll remember from our chapter 2 discussion, deep means it lies underneath. There's also a basement membrane that it lies deep to. It is loose connective tissue and dense irregular connective tissue. So there's another layer which I don't think, maybe this might show it, but we talk about, yeah, here we go, the hypodermal layer, not technically part of the skin. So that's, you think about this, the hypodermis is here, you see that's where you see the fat layer. It's not technically part of the epidermal or the integumentary system. We mention it here just because it's there. But when you talk about giving hypodermic needles or a shot with a hypodermic needle, that's the area you're going through. You're going through all of this area into this area, and then the muscle lies beneath that. But the epidermis is the superficial layer. The dermis is deep. There's all the associated structures to the skin, and I'm sure you will start, if you haven't started this week, you will start next week looking at the skin in the lab. And just as an aside, remind Dr. Johnson that there are some additional skin models in the storeroom. We brought some more skin models, so there are some more skin models other than the ones that are in the lab. I'll try and remember to send him a note. But for those of you who are in Dr. Johnson's lab on Monday, say, hey, Dr. Johnson, Mr. Russell said there were some additional skin models in the storeroom. The associated structures, these are things which are found embedded within the cutaneous membrane. The sweat glands, the sebaceous glands. Sweat glands produce sweat. Sebaceous glands produce a product called sebum. If you've ever heard of anybody that has a condition called seborrhea, that is an excess of sebum production, and the hair and the nails. Those are all accessory structures. The skin also has sensory receptors. That's where you can touch and feel. Erector pili muscles, which are associated with the hairs that are found on our skin. It's what gives those hairs the ability to stand up and fluff up and move around, like when you're scared or you're cold and the hair kind of stands up. The epidermis is avascular. We've mentioned that a couple of times before, which means it has no system of vessels. It has to get its nutrition through diffusion. The nutrients and oxygen and things must diffuse out of the blood system and diffuse through the cell layer. So it relies on diffusion of oxygen and nutrients from blood vessels in the deeper dermis, which limits the thickness of the epidermis. Again, that follows that gradient's core principle, which we talked about earlier in the semester. About 50% of your epidermal cells are too far from adequate blood supply to sustain life. Therefore, the superficial layers are made up of entirely dead cells. So those cells that you're leaving behind every day, everywhere you go, are dead cells that are just, the term is sloughing off and being left behind. The hypodermis is the superficial fossa or the subcutaneous fat layer. It's found deep to the dermis. It is not part of the skin. It anchors the skin to deeper structures like muscles and bone. It is made up of loose connective tissue and adipose tissue, has a very abundant blood supply. But again, the big thing we want to remember about the hypodermis is it is not considered part of the skin. Even though we've got epidermis and we've got the dermal layer, the hypodermis is not part of the skin. Cellulite is a condition where the skin appears orange peeled. It has multiple dimples. This is when collagen bands form around adipose tissues in the hypodermis. It tends to develop on the thighs, hips, and gluteal area. Not to be indelicate for those of you who haven't, mastered the phraseology yet. That's your rear end. If you don't mind my saying it, it's your butt. That's the gluteal, and those muscles are the gluteus medius and the gluteus maximus. It can be influenced by many factors, genetics being a major one. Gender also plays a role, and the amount and distribution of fat tissue and age. So older ladies whose moms and aunts all suffered from cellulite, you're probably going to have an issue with it as well. The cellulite cures that you hear about, very little evidence that those things actually work. The only proven way to minimize is healthy diet, regular exercise, and these don't generally eliminate it altogether. But if you're eating a healthy, low-fat diet and you're regularly exercising, you're not going to develop a lot of fat. And if you're not developing fat in those areas, then you won't take on that appearance. Again, I'm sorry, ladies, but as you get older and you're a lady person and your mom and everybody and all the ladies in your family have it, you're probably a good candidate for it too. This is considered a normal condition. It's not a disorder. It's just the way that your body sort of packages its fat. Some people package their fat in just big things, so you develop big tummies or big hips. Other folks, it develops it in little bundles, and that's what creates the dimpled effect, is the area between all the little bundles. The integumentary system functions protection. This protects us from mechanical trauma, protects us from pathogens, protects us from the environment. The stratified squamous and keratinized epithelium provide a durable but flexible surface. It is a continuous barrier to invasion by microorganisms and pathogens, provided it is not broken or torn. Very few microorganisms and pathogens that can cross the skin. Contains cells of the immune system that destroys pathogens before they invade deeper tissues. So those few microorganisms and pathogens that are able to make their way in past the dermal layer, there are parts in the epidermal layer that take care of that and get rid of those. Glands secrete antimicrobial substances. We refer to this as our acid mantle. The secretions on our skin give our skin a slightly acid pH. Most pathogens can't grow in that area. Provides protection from environmental hazards, including the absorption of UV light before deeper tissues can be damaged. And the glands secrete hydrophobic lipid-based chemicals which repel salts and polar solvents and keep them from both leaving and entering the body. Sensation enables the nervous system to perceive changes in the body's internal or external surroundings. This is very critical to homeostasis. You have to be able to perceive those changes if you want to change or correct those changes. There are numerous sensory receptors in the skin that detect changes in the internal or external. And we can also detect potentially harmful stimuli, heat, cold, pain, which could lead to damaged tissue. My wife can find anything in her purse simply by feel. She reaches through there. We can be in a dark movie theater, although we haven't been to a movie in years, but we can go. She could reach in there and she could find a chapstick. She could find, anything she wanted in her purse. She could just reach around and find it by feel. She can even, reach into her little coin slot on her wallet and tell the difference between nickels, dimes, and quarters by their feel. And that's using those sensory receptors. Thermoregulation, that's temperature control, relies on a negative feedback loop for maintenance. Again, feedback loops, core principle we talked about earlier. The internal body temperature is determined mostly by muscle activity and chemical reactions. The reason we shiver and shake in the cold is to generate heat. Sensory receptors in the skin let the body know that we're getting cold or we're getting too hot. The control center in the hypothalamus acts as our thermostat, receives input from those thermoreceptors, processes and responds. Then the chemical control stimulates sweating if we're getting too hot, or shivering if we're getting too cold. Again, when the temperature rises above the normal range, the control center will stimulate vasodilation. Vaso has to do with vessels, dilation getting bigger, so the dermal blood vessels widen, which increases the blood flow through the vessels, which increase the heat radiated from the body. That's why people with a temperature appear light complected people will, especially around their throat and their face, you'll see sort of a flushed red appearance. That's because the blood is moving to the outside to help lower the temperature. When those thermoreceptors no longer sense temperature above the normal range, they stop signaling the hypothalamus, which ends the responses, the sweating stops, and the vasodilation ends. Again, effective response, the blood vessels in the dermis dilated, heat's released. There's the sweat glands producing sweat, keeps the body temperature in the normal homeostatic range. When the body temperature drops below normal, usually due to cold environmental conditions, those, again, same thermoreceptors detect it, relay the information to the thermoregulatory center, aka the hypothalamus. At this point, the vessels in the dermis vasoconstrict. Again, vaso has to do with vessels, constrict, get smaller, which reduces blood flow. Heat loss is then limited, and we keep the blood inside our body, which keeps our core warmer. Vasoconstriction redirects the blood flow to deeper tissue, again, conserving heat. And then when the body temperature returns to normal, those receptors stop sending the signal and normal blood flow continues. So again, we're going down, the receptor, control center sends a signal, bring all the blood back in, warm the body back up on the inside. Excretion, we talked about this the other day. I asked you to look it up. What's the difference between excretion and secretion? Secretion is the body makes a product that's beneficial and secretes it. Excretion, we're going to eliminate waste products and toxins. Most occurs at other organs like the kidneys. However, the skin and accessory structures do make a small but significant contribution to excretion. Here's one of the things students find out when they take A&P1 that kind of grosses some of them out is one of the components of your sweat is urea. That's also one of the major components of your urine is urea. So some of the same components that are in your urine are also in your sweat. And skin plays a major role in vitamin D synthesis. Again, I've mentioned before, I'll mention again, vitamin D, the only vitamin that we have the capability of making ourselves. All the other vitamins that we have to come in our diet. Vitamin D is a modified cholesterol molecule. In other words, we take cholesterol and change it. Therefore, cholesterol is referred to as the precursor molecule. Converted into cholecalciferol. I will never ask you to say that word, don't worry. but it's done so by exposure of the epidermis to UV radiation. This is the vitamin D. We can make this by going out into the sun. The CCF is released into the blood, modified first by the liver, then by the kidneys, forming calcitriol, which is the active form of vitamin D, which is required for calcium ion absorption from the small intestine. As I said, on average, human beings need to spend about 30 to 45 minutes a day in the sun to make enough vitamin D for themselves. Most of us get our vitamin D either by taking a little pill in the morning, or children especially get it by drinking milk, because all of our, well, not all, most of the milk you buy in the grocery store, you'll see on the label says vitamin D fortified. Calcium ions are critical in nerve function, muscle contraction, building and maintaining bone tissue, and many other physiological functions. We will find as we move through the organ systems and look at the physiology of the organ systems, you're going to find out that a lot of the physiological reactions involve calcium. Most people, when they think about calcium, think about bone tissue and bone structure, but there's lots of other things that calcium is involved in. All right, we're going to go through, I think, one more module. We'll talk about the epidermis, and then I'll cut this one off for today. So the epidermis, the most superficial layer of the skin. It's composed of several cell types. You have the keratinocytes, which make up about 95% of the epidermis. Their structural features make the epidermis stronger and less susceptible to mechanical trauma. So if you have an elderly relative, I have a mother-in-law whose skin, and my dad, before he passed away, his skin had gotten to the point where just literally, if you did this on my dad's skin, he would bruise. If you do this on my mother-in-law's skin, like if my mother-in-law were to she's very unsteady on her feet, and if she were to start to fall and you were to grab her, you more than likely would tear her skin, preventing her from falling. Her skin has gotten just that brittle. And what is happening in her skin is these cells are starting to reduce in number. It's the keratinocytes that make it durable and less susceptible to mechanical trauma. As that number starts to decline with age, the skin will become more easily torn and brittle. They manufacture keratin, which is a tough fibrous protein. Again, that structure and function, core principle. It's made the way it is so it can do the job, and it does the job because of the way it's made. These cells are linked together by desmosomes, which are junctions that hold the cells together. There's several layers of the epidermis. There is the stratum basale. It used to be called the stratum germinativum. It's a single layer of stem cells resting on the basement membrane. So this is the layer of cells where new cells are coming from. The new cells are being produced by the stratum basale. It's the closest cell to the blood supply. Therefore, they are the most metabolically and mitotically active strata. This is the area that's responsible for vitamin D synthesis and replacement of the dead keratinocytes, which are lost on the superficial layer. The 5 structural distinct strata, you have the stratum spinosum, which is the thickest layer. It's on top of the stratum basale. It's still close to the blood supply, so these cells are metabolically and mitotically active. The stratum granulosum is 3 to 5 layers of cells, prominent cytoplasmic granules with keratin bundles and lipid-based substances secreted by exocytosis. These are hydrophobic lipids, or contain hydrophobic lipids, which provide the waterproofing layer, maintains internal fluid and electrolyte homeostasis, leads to isolation and death of cells in the layer, in this layer and more superficial layers. The stratum lucidum is a narrow layer of clean, dead keratinocytes. Notice it is found only in what is referred to as thick skin. You have 2 types of skin. You have thick skin and thin skin. Thick skin is found on the palms of the hand and the soles of the feet. Thin skin is pretty much found everywhere else. The stratum corneum is the outermost layer, several layers of dead, flattened keratinocytes with thickened plasma membranes, filled with keratin bundles and little else. These are the cells. Again, there's that word sloughed off or exfoliated mechanically as the desmosomes holding the cells together are lost. So, I know I stepped out of your field of view. I'm hoping you can still hear me, because the squeaking you're hearing is me erasing a board. All right, so there are 5 layers of the epidermis. There is the stratum corneum. I'm writing these on the whiteboard. I'm going to try to roll it over so you can see. Yes, you should be able to see that. Now let's find a marker maybe that you can actually see. The stratum corneum, the stratum lucidum, the stratum glantivum, the stratum spinosum, and the stratum basale. Now, oops, sorry about that. Name change. Stratum granulosum. All right. I'm hoping you can see those on the little board. Again, the red marker doesn't write very well either. The black one didn't write hardly at all. But what I want you to notice is the first letter of each word. Educators have known for 100 years or more that when students need to learn a list of things, they do better learning that list if they can associate the list with something. Like we learned in elementary school about a man by the name of Roy G. Biv. And if you didn't learn about Roy G. Biv, that's the colors of the rainbow. Red, orange, yellow, green, blue, indigo, violet. If you aren't, I was taught another, these are called acronyms or something, anyway. But I learned this one from a geography teacher in elementary school. The 5 Great Lakes found in the United States. If you remember the word homes, Huron, Ontario, Michigan, Erie, Superior. It's the word homes, and that's the Great Lakes. So we come up with all kinds of these, and there are bunches of these in an A&P class. There's one for the bones of the wrist. There's one for the different, I'm going to think of the word in a minute, cranial nerves. There's all kinds of these little word games that you can play. And I have one for the 5 layers of the epidermis. And it just so happens that this is from the outside layer all the way to the inside layer. So you have the stratum corneum, the stratum lucidum, the stratum granulosum. You have the stratum spinosum and the stratum basale. If you'll remember this sentence, you can remember this. If you remember that Canadian ladies give superb back rubs, you can just remember when you come on to your test in a couple of weeks on the epidermis and you have a short answer question that says, name the 5 layers of the epidermis, you're going to say to yourself, Canadian ladies give superb back rubs. And then you're going to remember that each one of those is the stratum something. And then you're going to remember that Canadian ladies, corneum, lucidum, granulosum, spinosum, basale. Canadian ladies give superb back rubs. Typical medications are typical topical medications. Certain antibiotics are fairly toxic if taken by mouth. However, they can be applied to the skin with minimal risk of systemic absorption. They contain polar molecules that cannot pass through the epidermis to reach blood vessels in the dermis, which allows for local effects only. So if you've got a triple antibiotic ointment that you put on, that is a topical. It's for the dermal layer. You're trying to get rid of a skin infection. You're not attempting to get rid of a gastrointestinal infection with those things. Non-polar substances cross the epidermis more easily, which provides convenient routes of administration for certain medications, such as the hormone and birth control patches. There are ladies that have gone through menopause that may be getting their estrogen or their progesterone hormone replacement through a patch system. Unfortunately, many poisons and toxins are also nonpolar, which can cross the epidermis with ease. So it's a good idea that's why it's a good idea to wear gloves when handling chemicals. There is a heavy metal called thallium, which you hear about if you, like me, are a fan of the police dramas and the police, what they call periodicals, things like Forensic Files and those kinds of things. Thallium poison has been used lots of times throughout history to get rid of somebody that you don't like anymore. Thallium was a product that was used, I want to say, in rat poison up until just about 50 years ago. It was very commonly, very easily acquired, and it was the major component of, I believe it was rat poison. It can be found on it could, not anymore, but 50, 75 years ago, it could be found on virtually every farm in the country would have a rat poison that contained thallium as its active ingredient. Remember the strata? Oh, brilliant studying gives loads of confidence. Okay, that's from the bottom to the top. I like mine better. Canadian ladies give superb back rubs. But see, Canadian ladies give superb back rubs. But a simple trick to remember the strata. Think of B in basalia standing for bottom, and it's the bottom layer. Okay, that's one way to do it, I think. But anyway, either way, I did not remember this slide was here. So, you've got two different ways to remember the order of the layers of the epidermis. And the life cycle of the typical keratinocyte is that the location and function of the epidermis is subject it to physical and environmental stress. The stratum corneum continuously sheds those dead skins. They must be maintained and replaced. Dead keratinocytes are replaced by mitosis in the stratum basale and spinosum, where the blood supply is available. Those keratinocytes will then push the cells above them into more superficial layers. Ultimately, everything just works its way to the outside. The keratinocytes begin life in the stratum basale. They pass through each epidermal layer and shed from the stratum corneum. Migration from the deepest strata to the strata corneum takes about 40 to 50 days to complete. So from the time a keratinocyte is air quoting here, born, its life cycle moves it through the other layers, and in 40 to 50 days, you will slough that one off and start a new cell. And then here is the example. Here's your new cell being formed, and it gradually, here's the B, see, and it starts to work its way up and pushing other cells out of its way as it goes. And let's stop there for today. We will pick up with other cells of the epidermis the next time we meet. Have a great afternoon or morning, depending on when you're listening to this, and I will see y'all.